Hello, Professor Sargent here with you again to talk about multiplying and dividing radical expressions and simplifying our answers when possible. This first one, we've got two options. The first one, I don't particularly like. We could simplify that square root of 27. If I just focus on that for a moment, the largest perfect square that will go into 27 is 9. It goes in 3 times. So the product rule would tell me that I could split up the multiplication. Take the square root of the 9 and get 3 square root of 3. Then I would have to distribute the square root of 3 out here. When I do that distributing, parts that are outside of a square root, I'm going to put in front like a coefficient. So distributing square root of 3 to 3 square root of 3, putting the 3 outside in front. Same thing for this. The square root of 3 times square root of 3, there's a few ways we could view this, but we could go with the product rule in the other direction, put them together, and do the multiplication inside. Square root of 9 is 3. And I already had a 3 out there multiplied in front. So we're going to get 9 minus 3 square root of 3. That required putting something back together where I'd already done some breaking apart. So in option 2, I'm going to show what happens if we just distribute the square root of 3 to begin with. If I distribute the square root of 3 to the square root of 27 and the minus 3, I'll put the square root at the back, a coefficient in front. Working with the product rule in the other direction, put the 3 and the 27 together, multiplied together inside that first radical. And 3 times 7 is 81. Although that's larger, it should still be recognizable as a perfect square. Square root of 81 is 9. If you go back a bit, you should see that's the same answer I had in the end for option 1, but this approach is a little nicer. The distributive property is something we'll need quite a bit of,